Hello everybody, it is Caleb here, and today I'm going to be doing something a little different than what my channel has done in the past. I'm going to be showing you guys how to put props on multiple people's faces, and I've got my imaginary friends here and here to help me with that process. So the first thing I am going to do is kind of show you the process. So the first thing we're going to do is take a raw video feed, which is right here, and we can do that, or we can take simply textures or a video. We're going to downres it as visible there, and we're going to pass it into an OpenCV script. This OpenCV script is going to analyze all of the faces in the scene like it's doing now, and then it's going to write out that data, transform to a table. That table is seen right here. So if my face goes out of sight, suddenly there's only two faces. And if I eliminate her face from the scene, oh, well, it still sees mine. But the OpenCV, so here we see the separate face tracker. OpenCV doesn't see my face yet. Now OpenCV sees my face. So let's undo that. So here's the benefits of OpenCV and why we have to use it with the face tracker chop. The face tracker chop by itself cannot see multiple faces. It only sees the largest face in the scene. So here it would recognize my face. Here it might recognize the imposed faces. So OpenCV excels in pointing out where multiple faces are, but it does so in a very kind of jittery way. And so because of that, any props that are applied to people's faces might become very jittery. Or what my previous project used the OpenCV location right here for the camera feed to go into the face tracker chop, which also didn't work because then that feed was very choppy and then the texture came out choppy. So this was the best solution that I came up with. If I have the transform X and Y of everything on there and I just need to not let other face track chops see the other faces in the scene, then I can pass this information to a process that applies squares over everybody's faces. So that's what happens here. And you can see that the square moves depending on where my face is. So that texture right here that this one is passed into the face tracker chops, and that's where the prop is applied. From there, we have, in this setup, we have 3 different faces that can have props applied to, and then their textures are merged and put together, and then any post-process effects get applied. So what we want to make sure of, alright, so I kind of walked you through this already, but we're going to build this exact thing in a new project. This is going to be our sample, even though it doesn't have access to any of our video feeds because they're all being tied up in a different instance of Touch Designer. But what we are going to do is kind of keep it handy so that we can reference it as we build this. So what I'm going to do is minimize this. I should save this under a new name, otherwise I'm going to get these confused. And I know I just instanced this name. Okay, so I am not going, I know I said I would be starting this blank. I am going to leave what Scott Allen built because it is tricky and this video is going to go on long as it is. There's no point in me discussing what's already been discussed. I do want to give a big shout out to Scott Allen for preparing the OpenCV end of this workflow. I wouldn't have been able to do this without him. So he has a video up and it explains in detail how to create this system of OpenCV tracking. He provides a script that is very similar to the one I have here. Mine is just built up a little bit in ways that I'll explain. So I do want to let you guys know that I won't be discussing how to implement OpenCV. We're going to start with this, and I want you guys to check out his video and build what he built. And what that does is get rectangles over faces and get the data prepared to be printed. So here's the project we're going to start with. We can actually delete this and we can leave this up. I went ahead and put some stuff into boxes to save a bit of time, but this is just a video device in, and if you want to look at all my settings, here they are. This is a USB capture HDMI by Magwell. And then I have a video of faces that I have ready to go. And then I have these two faces sort of combined. And then I have that as an option to layer over this, or I can just take from this. Now, quick note, if you're going to change video sources, what you're going to want to do is pause it and then connect your new video source. So let's say I want just these faces. The reason you want to do that is I previously put this up to a switch and then had a slider. And what happened is for about one frame, there is no video source and it freezes your software. So it's just much cleaner to have this. Just hit space bar to pause it, by the way. Space bar pause. Put in your new source, unpause, and there you go. But let's do these for now. I want to go over the changes and why I have to start like this, because I'm going to give you guys this script to start with, completed. And there's a few changes and things that need to be added for this to work. The first is this frame here. So when Scott Allen left the script off, it ran on the onCook function, which it still does, except it ran every frame. Here, I'll leave this up. It ran every frame, and that wasn't ideal. That's the wrong texture to leave up. So what I did is instituted a way of every time the CPU cooks or passes a frame in this program, it increments this operator right here. I had to have it increment something external because otherwise it wouldn't increment. I'm sure there's a way to use a global variable, but I haven't gotten there yet. So most of the time it is just, so this here says if frame table is over 20 or equal to 20, execute this script. Otherwise, add 1 to it. So 1 out of 20 times here, it is just adding to the script. That takes almost no CPU. Then 1 out of those 20 times, it actually executes this and updates the table with my face position. You can see my frames per second is 60 over there. What this allows me to do is turn up my frames per second here to whatever I want. So that being said, I wanted to show you guys this, but it's probably, here, I'll up that a little bit, probably not going to get used. Well, it's definitely not going to get used, but you might be able to use it. If you need a way to cause your program to go to sleep, basically, to really reduce the frame rate, here's what it is. Time.sleep, and then you have to calculate your time per frame by entering in your desired frame rate and then dividing 1 by your frame rate. Now, just note that while this does work, it'll slow your frame rate down to, well, you can see my frame rate stuttering now. It'll cause that to hiccup, and it'll entirely stop the CPU. So if I say time sleep for 4 seconds, I'm not going to do it because this is on the onCook function, and that's going to be hard to unpause. But if I were to say time.sleep4, Touch Designer would stop working for 4 seconds, which isn't always what you want. So I'm going to delete this now. But I think this system of an if-else that fires every number of frames, like if I want to speed this up, I can turn it to 3, and then this will update a lot faster. But for most applications, I don't need to do that. I can do 15 now. So you need this frame table. And then, so that said, I can get rid of import time because that was used for the frame rate. And then I can get rid of frame rate and time per frame. So the other thing you need is this table, and you can call it whatever I want. I left whatever you want. I left mine at table 1. As long as it's referenced in here, stats is pointing to that table, and then stats is then, you see I still have some instances here where it references the table exactly. But that's what prints the information to your table to be used later on in the script. The other thing that I have done on this script here, and ChatGPT came up with this one and actually helped with a lot of the code. But where was it? Faced. I believe it's just this line. It might be this block too. I'm not exactly sure. But what this does is, if it weren't for this, the data that's spit out here, these would be constantly bouncing back and forth. What this does is it sorts the faces based on their X and Y, based on these two columns, TX and TY, added together. And that keeps the data consistent and smooth, and that's what helps get a smooth track. If it weren't for that, these indexes would be changing their position because it would be shuffling them around constantly. I believe that's it. Let me scan through this real quick. Frame table, that's my thing. Script op is Scott's, Gray's his. These two. So there's 2 factors in, and oddly there's kind of only 2, to alter OpenCV. And that is a parameter in here that you apply to detect multiscale called min neighbors and scale factor. Min neighbors is, I believe it's the minimum number of boxes that can appear next to another box, if that makes sense. It doesn't make much sense to me because I only read it like twice. But yeah, that's min neighbors is a factor that will help with your performance, and then scale factor is a big factor that will help your performance. This is a number that ranges from 1.01 up. Basically what happens is when OpenCV is scanning a texture for faces, it'll start in one corner and will draw a box kind of around a certain area. And then we'll scan the entire frame with a box that size, and then it will reduce its size. The scale factor is what it reduces its size by. So if it is set to 1.01, it's going to take 100 times of it shrinking its size and rescanning for it to complete a cycle. And your GPU, you're going to hear it. You might see it. So if you set this, I set this to be 1.05 so that it never gets down to a number too low. So what this is I'll make one real quick. It's a slider. And then that outputs 0 to 1. So that goes to a math node. So for min neighbors, I have it 0 to 5. And then for scale factor, I have it 1.05 to 2.1. 2 being, it would probably only scan it once. And 2.1, I just left that on there just in case it does something and I find out that it does. Then I go to a null, and then how I reference that in the code is through this line. Right here. Scale factor equals float, parentheses, so float of what this number is. This number is operator scale factor null, which is that. And then, oh really, that unhighlighted it? Yes. Operator scale factor null. And then the channel, that has to be in quotes. And then the channel also has to be in quotes, but it's around brackets. So channel V1. Then close parentheses. And then what I do is round it to only have 3 digits because I don't want to feed too many digits in there. And then the min neighbors, that's a little bit simpler, so that can be called directly. I actually don't know if this round line is needed. Let's try it. No, it's not. So we can just delete this. You know what? I'm just going to uncheck it. Wait, I'm just going to check it. So that if we need it later, we can get it. So those are 2 or 3 dependencies. There's these dependencies that you must add, this table that you must add. This is not used in here, but you can add it now. All it is a simple table by going det and table. And then you turn exact dimensions on and set it to 2 by 2. And then what this does is it serves as a global variable for your resolution that you intend on using for your project. So for this is 1280 by 720, but this gets used so many times that if you were to change how your project is used, you're going to have to go around and update your position, your resolution many times. So that's what that is for. And past that, that is all the dependencies that you need. I'm just looking to make sure. So if you get to this point, you do need Scott's tutorial past this point. So get to this point and then we can move forward. What happened here? Oh, so one more thing. So this is kind of the bank of props, and I'm going to be adding to this later. But what this is, you can start with 2 or 3 or however many you want. I added this one, a reorder node here, just to quickly change what one looks like. So all this is a movie file in top. and then that goes to a fit node. There is no, well, I don't think there's anything special about this fit top. I think it starts with resolution 1000 by 1000. And all this fit top is for, so let's go to, oh, we can't do the flower on my hair anymore. When the flower was in my hair, it was more like on my eye. So if I wanted to correct that, all I would have to do is raise this translate to be a little bit off. I might have to shrink it down so that it fits. I've actually yet to figure out how to maneuver props that have to go outside this normal range. I will update a video once I figure that out. So fit and then to a null, and I just do the null for good practice. That then goes to a switch, and the switch that we use is on a slider, and that slider, the range is from 0 to 1 to 1 to this line right here. And what that indicates is a table that we haven't made yet. It's a table called prop data. And what it is, we're missing a script. No, we're not. It's right here. So there's a script that goes with this. Oh, we have a sleep here. I need to get rid of that. So what the prop table is let's check back at our other project. It looks like this. So let's do 6 columns just like this. 0, 1, 2, 3, 4, 5, 6. Wait, that's 7 columns. And I will show you how this gets filled. The prop table is also a necessity to this. There's a lot of little necessities to get this to take off. Once we do, I think you'll find it goes together fairly simple. So columns, we're going to have 6. I guess we do need 7. And then rows, let's just have 4 for now. So go ahead and turn this on, and then we are going to name this exactly so that we don't have to change any script here. Table prop data, and then we can kind of build our header. So this first cell is name, second cell through that is, I have these parts for multi-part props, and I haven't gotten that far yet. So again, I'm going to update more, but what I want to do is leave the system kind of there intact for it, especially since we're outputting strings to these next two. So name, let's go for our first one. What do we have here? Glasses, flower, nose. So let's go. And then second one is flower. Third one is clown nose. And then for the part, we refer to this chart. And I'm going to give the link on where to download this, but yes, it should be provided. So Thug Life Glasses is going to go right on the bridge of our nose at 28. Flower is going to go on 1. I think I had it on like 18, but that was my eyebrow last time. And then Clown Nose is going to go on 34. Now, what this script does, I'm not sure why it's not running, to be honest. So let's debug this for a bit. Clearly it's not even reading this table because I mislabeled this, and it's clearly not. So let's just try bringing in a new script. I think I deleted something here. There we go. Then let's just copy this over, and that should do it. Okay, it's going to give an error. Good. I like that. It means it's trying. Prop data, let's change this name back. And say try again. Okay. So there we go. So now it did what the script's supposed to do, and it creates a string that can be used later on. I believe we have all of the data we need. We have created our prop data table. So now what we have to do is this slider that goes to this math, we have to have it point to, well, it looks like it's good. It just needs to know that. What it is op table prop data, which is this one, dot numRows, which is the number of rows that this table has, -1 because to account for our header. Now, as for this being still errored, we should just be able to reconnect it, and there we go. So then this will change the prop that we place. And if we want to add another one, it's as simple as saying, now you have 5 rows, and then purple nose, and let's say we wanted to cover our right eye. We would say it's 0.47. The script takes care of our point. And then this knows that it goes down to another row, and then it switches to the purple nose. So we have everything we are dependent on. We can start building. We are going to refer to this. So the first thing we need to do is take these two dat2s. I will explain what we will do with them in a second, but basically our first step is to get the square stats. That is the transform x, y, width, height, index, and if it's active. And then apply it to our resolution and our scale x and y in. So let's do that now. The first thing, let me do this real quick. Okay, I thought I saved over this project for a second. So let's get started. Like I said, the first thing we have to do is make our dat2s and then rename them. Now note that we're going to be building one row at a time and then go from there. So let's extend this into a dat2, chop, and then we are going to select row by index, first one being row 1 because we have a header. First column, that is going to say, it's channel per value. There we go. And then we output out of there into a rename. If I could type. And what this does is it lets us see what parameter is what later down the line. So our cheat sheet's here. It is from star, which means all, to index, space tx, space ty, tw, th and is active. Okay. And let's make an annotate box so that we can see what's going on. By the way, I want to show you guys something. I was playing around with shortcuts and I hit Shift A to make an annotate box, and out of it came this color palette right here, which I think is awesome. I'll post a little note on how to open up that color palette by itself. But anyway, Shift A makes an annotate box and also opens that up even after you close the box. So that's pretty rad. So this is going to be so after we rename this box, then we have to select everything. And this is actually going to live back here, and then we're going to kind of get into it right here. So let's click out of here, do select, and from what I understand, this is just TX on all four of those, and then index and active. So let's do that. Channel name, select TX. TY. Oh, you know what we should do? Just backspace. Paste as many as you need. I'm going to need 6. 2, 3, 4, 5, 6. And then select them as needed. I think is active is last. And then we also, we want to make sure that we're seeing our faces data in there. So this is selecting face 1. I hit D. We're not going to get the second one yet. What we're going to do next is normalize these values. So in our other project, they get, what this does is it changes the funky values that come in to a 0 to 1 scale. And this makes things a lot easier to mess with when you're building it later on. So let's kind of, here to experiment with this and show it, paused, and then I'm just going to bring in my face. So we could see my face is here. It's now the only face it sees. So notice that this goes from a range of almost 0 to almost 1. So we don't need to change this value much. We're going to put a normal, or sorry, it's not a normalize, it's just math. And I call it normalize. And we're going to do it anyway in case we need to do it. And it actually turns out that X is one of the few parameters that doesn't need it. So let's go to our Y, and we can see that in our other project, X has these stats. So 0 to 1, 0 to 1, nothing added. That's pretty just normal. It's almost a null. This one has some values though. So I want to pin this up here and pin this one here. So this one, range 0 to 0.45, and that ranges from 0 to 0.84. The reason why is because this is the vertical, and if you watch this, I kind of don't like this annotate here right now. If you watch this value, if I go all the way down, where's my face? See, it doesn't go all the way to 0. And then it also doesn't go all the way to 1. So this was my way of adjusting for that. I don't know. I forget why that worked exactly, but it did work. And then we have our width, which in here goes 0.01 to 0.5. With no pre-multiplies. So it's from range 0.01 to 0.5. That's the value that width gets as I zoom in and out. And then height, in this case, is 0.01 to 0.5 as well. So this gives us a scale value normalized to a value that we can agree on. Our next step is on the transform x and y, we need to shift it from a value of 0 to 1 to a value of negative 0.5 to 0.5. And that is because we have to measure transforms. So this will be negative 0.5. This will, well, I think it's the other way. This is 0.5. This is negative 0.5. So let's do that. And all we have to do there is do a math node. And then just subtract 0.5 by adding negative 0.5. And it is the same for y. I could have probably put these both into one node, but I wanted to make things easier if I come back later, kind of forget how I did things. So after that, we transform everything to a pixel space. It becomes much easier to work with later down the line than working with fractions. So to do that, I'm going to go to another math node right here, and then jump out, connect my y. And then I have to bring in my, if you can't tell, this is going to outline a function. I have to bring in, speaking of which, this really needs, oh, I should have done this earlier. This needs an in, and then everything needs to run off of that, so that we're not plugging in multiple inputs. And then things work the same. So what we need to add is an input on the dat table. That is going to get our resolution. And we can make this a little bigger. And then from here, we can reference these cells directly. So let's call this res in, and then this pixel space. So we're given a range near negative 0.5 to 0.5. It's big right now because, or it's not very close because it's measuring the center of my head. And A, I need to do this to get that number close, and B, it's still right here. So it's not all the way to the side of the screen. Anyway, how the math's going to work out is this number multiplies by, if I remember right, yes, by the resolution. So all we need to do is say from range 0 to 1 to range, I can just copy it across here. It's operator, I changed the name up a bit here, res in, and then the cell is 0, 0, right here. So then to address 0, 1 for the y, I just copy this same call and punch in the new coordinate. So now we have the amount of pixels that we are offset. We can see if we display this, this is going to be 420 pixels offset. This is going to be almost negative 400 pixels offset. So that is good. We are making progress. Let's save before something happens. We do have to convert our width and height to pixel space. So let's do math. And then we are going to take in a variable called, let's bring this off display. We are going to take in two variables called scale X and scale Y. And this doesn't represent the scale of our prop, it represents the scale of the green blob that's going to cover our face so that other face trackers don't see our face. I like for variables that are global to go just off constant values. I think they're easy to change. If you want to up these to sliders with math nodes, they're easy to change as well. So scale X, I'm going to set it at a number I find works is around 1.4, 1.3. And then scale Y is going to be around 2. We can feed these in. And then all that we have to do, I believe, is multiply. So if I look at this, I can see that I set static values to this. What I'm inclined to do on this build is get these to truly work with the resolution. So what this is, let's see, I did 700 for the width. So that's about times 0.6. So I'm going to say that this is, just follow along with me, and if something happens down the line, we'll know what it is. So this is going to be operator resin 00, which is 1280, times 0.6. I'm aiming for 700, so let's go 0.55. There, that's closer. And now that works off our resolution as well. This number down here, I dialed in. Why is it multiplied by? Oh, because that's the scale thing. To range 400, so I am going for 400 here as well. So copy that, paste. That gives us 796. So that's like half exactly. 398. That's close. Let's do half. Okay. Where is my, I don't have a dependency here for some reason. I swear I set that. Okay. What? Why does it take the other one? And how does it? Well, no. For some reason, it's not keeping this import. Now watch. Will the other one go away? No. Okay, good. So all four of these are imported. When I left off, we had left off with a pixel space of how big, why isn't that updating? How big and where our square is going to fall. It should be only picking up my face right now. And the width and height are remaining static. So what scale factor is doing is that's what's causing these kind of round numbers, because it's skipping a lot of different scales. So here it gets a lot more scale numbers and you get different values. Basically here, there's only a certain number of values, but as we get lower, we get more values, and we can see our frames per second drops. So that's good to know that what that really does, because I was kind of confused by it before. Anyway, so for purpose of testing, let's turn this down. We'll use more CPU. We'll get more accurate results. 0.1. That should be plenty. It is good, though, that you have that much power over your CPU, because then it means that kind of a lot of people can develop this. So we have our width and height. And then I believe after that, we just have to output these values and seal this up as a function, because yeah, we have our pixel space, so we're done. So let's output these. And I like to call this TX. Oh, TY out. And let's agree to a naming convention here. It'll be type first and then out. So the more important info out. You'll know that it's an output. And then another out for the width. And then another one for the height. And then what I want to do also is pass our index. That can go straight to an out, because we're not really going to alter this. And then I would also like to do the same with our active. Once we have all that, let's Control S and save. And then we can go ahead and wrap this up in a container. How we do that is double click, composition, container, add. I like to enlarge mine just a little bit so I can connect the pins. And then we want to drag everything up to the inputs. So that's an in, these are ins, and we want to drag those inside the container, say copy into container 1, and then zoom in just to make sure that we have them. Once we have them, we can delete what's here. And then you can leave the annotation box, because it's kind of going to cover what this does. And that's just going to help anybody who looks over your programming. So I'll go back to my face if it was helping you. So what we're going to do is we have to go in here first. This is technically a function now, as you would find in other programs. We can duplicate this, and every change that we make to here will be replicated in the outgoing boxes. But let me give us some more room here, maybe. Yeah. So one thing I want to do, though, is scroll into here and then hit P to bring up your properties if you know it's not there, and adjust the connect order. So starting from data tables first, that's 0, and then starting from most important and most used to least important or least used. So it's going to be 0, 1, 2, 3. And then as for the outputs, I like to keep the pins in this order. They'll jump around order right now. So let's arrange TY to be our out 1, TW to be R2, TH to be R3, and that way these 4 especially will always be in this order. And then index 5, this is 3, so this one's 4, this one's 5. And it actually doesn't matter too much. You can adjust the slider and it'll kind of do things differently. But yeah, so now that we have that made, let's scroll out and then connect up our inputs. And actually we can shrink the size of this a little bit. I made the last project a little bit macro. Let's connect our, let's label these. So this is our dat chop in. Backup out. And then connect that to, I like to hover over it, dat chop in. There we go. I don't know why it's, oh. So then we have to connect our resolution. And then we have here, we might need to re-import these because we didn't label these channels. Then this, I'm just hitting Control C and then P, and I'm going to copy this to the channel name. And then these will serve as our inputs. And then, yes, we have to yeah, I don't think it's going to recognize this channel name. Oh, we didn't even do this part yet. So scale box in, now that we have these inputs, we can drag them onto our multiply here and chop reference. Note that you do have to have something going in here. If this isn't connected, you cannot set this part up. So display, drag over, multi-add. There we go. Now we can hit P, and then also note that in this mode, these channels don't always update, and textures really don't update. But if you do want to see what's going on, you can right-click it and hit Open Floating Network, and then you can see the values move. So let's save, and now that we've made our first function, let's go out and see what our second function is. It is the create square function. And this one's actually a lot more simple. If we go in here, well, we can see that the variables we need are our resolution. We need our resolution, that's right here. We need our 5 variables here, maybe 6. And then we need the full screen in after it's been cached by 1 frame, because OpenCV is used to generate where the squares go. That gets layered over our full screen, but we need to cache this by 1 frame to very accurately show it. Otherwise, we're going to have a slight discrepancy, and it's going to cause things to kind of just be less accurate. So let's get started with this. What's in here is our full screen input, not res down. So that would be this one, source, what we keep connecting to. And then I like to copy a null and then drag that over to where my variables go. So that's an input. Call that full screen in. And then our dat table in. And that takes our resolution. There we go. Now that we got that boring stuff out of the way, our rectangle that is going to be used to block over my face. Let's use my face. Okay, so there's my face. And we're going to make the block that goes over it. So we need a rectangle top. And then let's take two chop inputs. Let's call this res in. And then this is going to be our transform X, transform Y, which we actually don't need right now. What we need is our width and our height. And remember, these are in pixel space, so that makes it easier. So it's going to be these lower two, TW, and then TH. And it's only going to be these four if you set your connect orders right here. So once we have these, we can output these to a null, because we might have to change this value a little bit. I actually think I had them. No, I just have them straight wired. If we want to put a math node here, we can, but for now I'm just going to leave them out. So then take our height to a node and then hit P for properties. Resolution, we need to set this to be our output resolution. So once again, we can go in here and almost just take this because it's labeled the same thing. So rectangle res in, yep, that works. 0, 1, and then 0, 0. Okay. Now we have enough pixels to fill. And then we go to rectangle, size in pixels, and output these two numbers. And then I like to make this green just to add more cheer to the world. You can make it whatever color you want. So once we have that, I like to also layer this over a text. And this is going to be driven by our, let's go to null, in. This is going to be driven by our index value right here. And then we actually don't apply it to the text. What we apply it to is the append value. So let's star this, then drag this over value, chop reference, and then make 0 decimal digits because it's always going to be an integer. Now, if you'll notice, what that does is kind of shifts our thing to an awkward position. So when we go over top, I selected the wrong one. Believe this has to go over this. Yeah, what you'll find is that it stretches this. And I'm okay if it stretches it, but it pushes it off to the right. So I don't like that. The crude and dirty way to fix this, as I found, is just to shift this over on the over top. You shift it into place. It'll always be one digit unless you're adding over 10 faces, which if you do, email me. I've got to see this. And then that will keep an index of this. And I haven't done this before, but let's change this color to like black so that I can see it a little bit better. Okay, so once we have our matte to go over my face, now we need to tell it where to go. So that is going to go to a fit top based on my screen resolution. And hopefully this will be in your clipboard for most of the project. And then we need to fill a input fit 1280 by 720. And then let's go over and actually yeah, there's two outs we have to provide here. One of them is a monitor out. So let's go this over this. And then the other one, and I realized I still haven't told us where to go. The other one, let's call this one mon out. And then this one is square out. Or I like to call it box, less letters. So we have to tell this thing where to go. Once again, let's make a little bit of space. This is going to go straight to a null because it's already in pixel space. We're just adding this here to make things cleaner. Let's plug them in. And then this has to go to an id first, or to a fit. And then, right, this doesn't even need to go to a fit, really. Oh, you know what? I filled this with the wrong thing. So this goes to this one, not this. And then full screen. There we go. So this is the setup. Over to fit. This is your full screen resolution. And then the translate of that is this. Why don't I see it? Oh, you know why I don't see it? Because this is still in fractions. So we do have to remove these two operators. Change it to pixels. And then let's put these, wait, what am I doing? Back. So you change it to pixel space and then re-export. So transform X, transform Y. You have to be sure you're changing these to pixel space, or I guess I do, before, otherwise when you change them, they will just do the math for you. That math will be incorrect. Very high pixel count there. So now you can kind of uncheck these. And then we are good up until our kind of checks, so to speak. So we have our index. The only variable we're missing is active. So let's build ourselves an in chop for that. Take our variable out. And then what is active does, if you look over here, is it acts as a sort of, acts as a dimmer for this. So this constant is connected to this value, is active. So on the alpha layer. So nothing will come out if this is not active, if this face is not active. So let's build that. Let's go out a bit here, and then this goes past these. So this goes to a multiply top connected, and then we use a constant top to multiply it by. And actually, I'm sorry, I'm building this in kind of a backwards order. Let's disconnect this for now. Disconnect these outputs. I got confused with this. So this is the box that needs to be applied. And when this alpha goes to 0, there's no more box applied. So that when it ends up in no position, there is a control over that. And then this alpha layer is this value. Once that is done, then we can then pass this on to our outputs. So this can get put on an over. And then our box out goes to here. And our monitor out goes from our box out, box out layered over our full screen. So now we can see that the reason why it wasn't moving is it's covering his face. If we were to change this .2 or switch our video source, now you can see it's covering my face because it's the only face there. Well, and it's index 0. So if you can get to that point, awesome. I'm going to save here. And then once this is done and we have our two outputs, we're good to move this into another container. So again, we're grabbing everything up to the inputs and everything up to the outputs. Not our container itself. Drag into the container, and then we have to sort our inputs. So like I said, I like to put dat tables first, and then textures are nice to go second. And then, let's see, I left off on 1. So, and then my tx, ty, width, height. And then, oh, I got lost on this time, or last time. 5. This will be our, I think, index, and then this one's is active. Yeah. I can name these now. And then note that nothing's working because nothing is connected, but it's there. So we can delete all this, move our function in place, connect our inputs, full screen to there, resolution to the top, then X, X, Y, Y. And then I'm certain that these are, but I'm going to check anyway. TX, TY, TW, TH, index, and active. There we go. It'll remain X'd until you zoom in and see that it's still X'd. Looks like our value didn't get really conveyed across properly. So let's oh, it's because I changed the name here. Okay. So now that that's done, let's go ahead and back out. And then we have our first, up to our first texture. I'm going to take a quick break, and then I will be back to continue from here. All right, we're back. When we left off, let's name this. We got our square numbers and then created that texture, and now we have, if we output from this, which I like to do, this is our square out, so this is actually going to go to something else. I meant to get our monitor out, and that can kind of get fed. So my overall flow is, left to right, and then variables or inputs go up top, and then end results kind of go out bottom into the. So overall, I'm working upper left to lower right, kind of like you would read. So we can take our monitors and bring them down and kind of use them in almost a multi-view. But we're going to keep this one closed for now because we're only building out one string. As you can see in this web of texture spaghetti here, give you more room on the sample file. What happens here is they get algorithmed over each other, basically. Not permutation. I think that's the word. Should have looked that up by the third attempt on this video. But yeah, they get all layered together so that every single one gets layered over each other, so that the result is, if you have only one block up, you'll have two overtops with this block in it. We're not going to make that now though, because it requires the other rows. So we're going to leave that, and then we are going to go to this switch that you see right here. So let's move this back. We can annotate here. I like using these annotation boxes, even though they block out my face. So right click out of this to a switch, and then the index for this switch is our index for this row. So our index can be grabbed simply from here. But I don't want to, this is a null chop, and then I don't want to right click this, otherwise it will stick itself in the middle of this. Oh, forgot to grab our parameter. So let's take our index and bring it all the way over here to our switch, and that is going to get used for our index. And that will make a little bit more sense once we layer things over each other. I guess we don't need that much room. After this switch, if we go over to this side now, we go into applying our prop. And you can see we kind of have a whole bunch of variables here for this. One new one I added is the required confidence, and that takes over the isValid parameter that it provides. But let's continue. This is, oh, so after this, it goes to an overtop. It seems it went to an overtop just after this. So let's add one overtop in here. And then we'll just delete this. So what this overtop does, we're going to have another overtop in here later. This one is, we can rename this full screen. This one simply takes the full screen input. And then once it has that, that feeds into our switch, and then that determines what our face track chop sees. So let's add a face track chop. And then to set this up, you do have to specify your mesh file, which I'll provide, but there's a couple videos on how to get this set up. But model folder, essentially, you want to point that to your face model. So if I follow this, it would be C, program files, derivative, touch designer, config, models. And there I'd find face detection. I think that comes default, and then you have to add your graphics card and then specify your top. So usually this is a null, and this will exist in this function. And then usually this is downrest. So let's actually feed our switch. Well, our switch has to go to an in. So input first. And then this goes to resolution. Resolution will be half. That goes to our face track null. That goes to our face track chop. And then here's the settings we want to enable for this. Bounding box confidence. That what this gives us is its confidence that what it sees is a face. It should have higher confidence that it sees a face here. What happens if I change the resolution? Because I think I was using full last time. Yeah, it jumps way up. Oh, interesting. Well, now it knows where my face is. It must be seeing my face. Anyway, that was a variable. I'm going to use it because it worked better than isValid. And then we want to turn on number of landmarks 68 multi. And then I don't think we need to turn on rotations. Yes, we do. And yeah, that gives us the rotation of our face. So all of this data is going to be, well, not all of it, but we need it all available. So also in this, we need our prop data. So let's add a dat in for that. And then the other data table we need is our resolution. So let's go fetch both of those right now. Now that that's had, we can grab our data, and this actually needs to go to a select dat, which can be conveniently dragged over here because that's a long way to go. And then with this select dat, we select rows, by the index of our selection. More important is select columns. By index, we need to only use 5 and 6. And then for our prop selection, we need to reference this number. So we can go to a null here. If you like green wires, I kind of do once it gets to up here. Oh, well, I guess that has to go to an in. Anyway. Oh, that gets used for right here. But does it get used in there? No, because this is global. So this is global for all 3 props. If you were to individualize the props, then yeah, this whole thing, whole index would probably go into this function. But here we're just going to drag this out to both, and now we know that those are the 2 values we use here. That gets fed into our dat in. Now we have both of those. The other variables we need are, I'll get to that in a second. We most importantly need our textures. And I shouldn't call this full screen in. I should call it blocked in because it's getting the blocked input. The other thing we need is that a full screen? Oh, we need our, I can't even access the files. We need our prop texture. So let's use another top input. Call this one prop in. And then that parameter gets taken all the way from here. Let's see if we can make this connection. Nope, let's just drag it over. Plug in, and then we can pull this back. And then the other texture we need, because we want to run a monitor out of this as well, is our full screen in. So let's go one more in. And this is going to get our full screen, which is right here. And you know what we forgot to do is cache this. I said we would do that. So yes, when we create our square, let's come into here. And we have to cache this texture by 1 frame. Delay it, because it's going to be coming in a different time. So connect this to here, and then connect this down to here. And then our cache size is going to be 1. It's only going to hold 1 frame. I can kind of bring these together and show you what it'll do. And then step size is always going to be 1. That's just how many, that's the increment of frames that it'll take. Output index is going to be -1. And I think index will still work, but I like to specify frames. So note that if we up this to like 10 and output -10 frames, it's much more drastic. If we do 30, now you could really see what it does. So it delays our texture. We're only doing 1 frame though. And that is good right there. So let's go out. I'm going to save. And then we need one more parameter, and that is our required confidence. And in this project, I didn't down res this, I don't think. So, no, I did. Okay, so that is good. And then, yeah, let's grab our confidence. So chop in, and then let's make a constant variable. And let's do a pretty low confidence to start, like 2. Okay, and then that is going to wire to our input here, which is going to be our required confidence in. So how these are all going to play together is like you see over here on the right. It's going to look a lot like this function here. So start by normalizing, and by the way, these basically don't do anything. They're here for your convenience. If you need to make any adjustments to this, they're already here. But in general, I put these normalizes here because I thought I would need them. I ended up not needing them at all. So these are just 0 to 1, 0 to 1. It just feels weird wiring those straight across. So then we go to a math that changes it again to what am I doing? We need to select our tops here. Okay, so like I said, I forgot to add a select chop in here. So let's wire that in. The first thing we're going to select is, well, what we need is our string here. So we are going to address that by simply saying operator prop data in 0, 0. That is going to look like operator, what did I say? Prop dat in brackets 0, 0, which gives us our U. It didn't like that. Oh, because I have to tell it that it's an expression. There we go. So you click this plus, make it blue. Now it knows it's an expression. Copy and paste. And then you do that same thing, except it calls cell 01. So now what you have is a channel name that operates on a variable value. That lets you change what face point it's going to stick to. So we take that number, normalize it, even though it's pretty clean, add math to it to change it from a range of 0 to 1 to negative 0.5 to 0.5. And then we can change it to a pixel space. So I'm going to call this adjust, and then this one's going to be convert to pixel U. So then, just like we did with OpenCV, that pre-add, this is 0, I'm pretty sure. Yeah. And then range is 0 to 1280, which is operator res in brackets 0, 0. And then we can, I want to get as far as we can on this. Oh yeah, I like to rename this to simply say TU. It's just cleaner. And then that goes to a null, which gets applied to a texture. Okay, we can take this entire row here and copy it down and then plug our V into it. And everything should be the same. Let me check our values here. Okay, nothing here. That's normal. Convert to pixels. This has to be cell 1, 720. And then rename it to TV for transform V. Oh, it did this thing. So yeah, if all of these are selected when you plug something in, it'll kind of mess it up. Normalize, adjust goes to the normalize. Adjust goes to, or normalize goes to adjust. Adjust goes to convert to pixel. Pixel goes to rename. This has its V pixels, and then this gets connected. There we go. So now we have, after we feed our blocked texture in, and my head's a little bit too big. We'll get to that later though. After we feed that in, which will have only one face lit on. It's confused now because it sees two. Then we'll get the exact position in a cleaner data of where the prop goes. And that's in pixels going out. Luckily we don't need to output those. We handle the texture in this function internally. So next thing is this width. So what we're going to do, let me try to follow along over here real quick. So the first thing we do, it looks like, is multiply it by its what I call intensity. So the reason I used to do it off face 1 is valid, but then it'll do that if it even thinks it sees a face. So I want to apply some kind of variable confidence level to this. So that's why I started doing it like this. But you have to apply a little bit of math to it. That's okay though. What we're going to do is copy and paste this. And then from here, we can just go to a normal expression. And we don't need to worry about which prop we're on. We just need to get the confidence, which change it's based on how confident it is that that's a face. So what we did over here is run it to a math node, and that was actually supposed to run from this, but it looks like I turned directions. So let's go to a math node, and then drag in let's go to a null and drag in our required confidence, and then our math range is 2 of required confidence. And this is in percentage. So that means as soon as this hits 2%, this will get to 1. If this were 100, then it would require 100% confidence that it was a face to get to 1. What we're going to do is, I think this will work. On, where is it? Operator, integer, round. What I would really like is greater than. So we're getting a confidence level of 10%. So let's say this confidence level was set to 10. This would now be almost 1. So my goal is 10. Let's see how off it is if we just use round. If it's 9%, it's there. Oh wait, so I'm going the wrong way. What if I ask for 20%? Then yeah, it won't give me that. If I ask for 15%, so I think it's half. So if I ask for 17%, yeah. So that'll work for now. What I would ideally like is this number to get conveyed across. But right now, it'll trip if it's 50% of this number. So actually, we could just kind of work with that and say math. So a 10% confidence. Right now, this 20% confidence level is actually close to 10%. So we just need to multiply this by 2. And now we have an accurate number. So if we say, if we say 20% accuracy, it's now 20%, because round will trip over 50%. I think that'll work. So then this is a number from 0 to 0. This will technically go past 1, so I like to limit it to 1. Once we do that, then we can pass it into a constant that gets multiplied by our prop texture. So let's go to a constant top here. Let's take this to a null, and then confidence is this number. And then that gets multiplied by our prop. So let's right click, multiply, bring this over. And then multiply these two together. So right now there's no confidence that it, well, also I'm asking too much. Let's give it a required confidence level of 2%. There, now it says there's something there. So now that we have verified our texture and have shut it off if it's not verified, we can add in our rotation. We haven't gotten our rotation yet, so let's do that. Control C, Control V, and get our rotation. It's RZ, by the way. And then we need to backspace this. And this is in degrees. So we can go out to a null. And I like how we're doing this with a clown nose where it doesn't matter. But basically, so after you verify this, it goes to a fit node, fit top, that handles its scale and its rotation at the same time. Now note that we need to get our width for this. So let me get that now. Control C, Control V. And this is simply face width. And notice that, let's go to a null. I don't have to get the width and height because I want this to stay square. So I'm only going to drop in, I think I just went straight in with this. Yeah. Did it go through any math? No way. Okay, I guess it just worked like that. So this will, no, sorry, not translate. This will go to scale. And it will drag to both the X and the Y. And it will be scale, well, 0 to 1. And then for rotation, that is right here. You can just simply highlight that and then drag it onto rotate. And then as part of our convention, let's keep that above. I actually like breaking convention here. That looks good. Okay, so I want to switch to a different prop than the nose so we can see what's going on. Let's go to glasses. That's usually the best identifier. I need to eliminate the other faces. I should just leave source up. Why is it having trouble? Oh, because there's a big green square over my head. Well, we're going to have to test that later then. But just know that this will be in a function and you can kind of address them all at once. And that makes things easier. So after we account for our rotation and our width, then we account for our position. And to do that, just like we did last time, go to a fit that is your resolution. So same call as these. And then yeah, see, it is struggling with the confidence level here. So we can drag these over. I know it's kind of hard to develop without being able to see, but if you look where the numbers are plugging into, fit, our translate then is our transfer or translate U and our translate V. That's how far from off center it is. Let's give it a temporary full screen instead of this blocked input, just so that we can make sure things are working. So normally we would be coming off this switch. Today we are coming in from blocked. And now we can see that, yeah, we do have a head. Its confidence level is above the threshold. Right now it's at 35. And I think it kind of refreshes when it sees a face. So I'm ducking out of frame, then it comes back and it's a slightly different value. But that's above the threshold, so we get a texture, and it does rotate as I rotate my head. Now what it's not doing is fitting on here, and that's because once again, I set this in fraction space. So I'll show you what happens now if we translate it to pixels. That's too high. So backspace, fine. We don't need a backspace. Just drag and re-export while it's in pixel format, and there we go. Now it works correctly. And then what I do next is I layer that over the full screen input, and that gives us a monitor. So once I layer this over the input, it should give us our proper filter. But what I'm going to do is cache this one as well. And this frame chop takes a face track chop takes a little bit longer than the other one. This one takes about 2 frames. So cache size is 2. Output index is -2 frames. And then that goes to an over, where it acts as the top input. And where's full screen? Full screen gets wired to the bottom. Once we have that, we have our prop. And then if we need to adjust it, we can do so right here. So we can say, I need you to go, let's drag this property box over here to where we can see. I need it to go, I guess it's 0.08 right now. I need it to go a little down though. And then even when I'm on top, it lines up. When I'm down, so we're good there. I could go with a slightly higher scale, but now we have exceeded our bounds. So where I should be applying that scale is, good question. So when it comes to scale and size, it would appear like I did some messing with this just now and it wasn't really working out. So the best way, it seems, is the way that I have. Here I want to use glasses. It would appear the best way if your prop is too small is to simply, we should have a prop size in here. Width, what does width go to? So what I'll do here, I'm pretty sure I have this in here and I just left it. Maybe not. Anyway, let's make two variables here called prop scale min and then prop scale max. And then I have to pause. Okay, so prop scale max, let's just set this to 2. And then this, I want it to still be something of value. Let's call this min prop scale max. So these are going to serve as more inputs for right here. Let's lower these down and connect them. Min to min, max to max. So now we have a value of 0.1 and 2. And then our width, that should range, so let's say 0. As for the max, yeah, let's do 1. It's pretty normal, 0 to 1. I'm gonna add this in here anyway in case we want to change it, but that's pretty solid. And then this will get, I'm not going to convert this one to pixel space. I might regret it. But this will get multiplied by fractions. So we have here a 0 to 1. So we can go to another math node. And then what this one will do is take these two exports. So from 0 to 1 will be a 0.1 scale to a 2 scale. And now we are scaling up our props. So currently it's receiving a value of 0.35. We're going to give it a much bigger value. And now it's way too big, which is good because like it does get smaller with my size. But before our problem was we couldn't make our prop any bigger. Now we just need to make it smaller. So now we can easily say scale 0.6. Now it gets it to the right size. And we're working down. Now we do have to change these other ones. But that's fine. It's much easier in this scenario to scale something down than it is to scale it up. That's way too big. And then I actually want to change this point. Right now it's 34, right? Yeah, let's make it a little higher, 31. There we go, maybe a little higher, 30. Okay. And then same with this one down here. It's gonna follow the same thing. And it's over my eye. So we could actually make it bigger, since it is absolutely nothing. Okay, so now we have our scale handled. That's a slight improvement over my previous model. Okay, so we have, like I said, our scale handled. And that applies the prop to our face accurately. So we are done with this row. We can now output our monitors, and those two monitors are our combined output. And then we also need to output just the prop. Okay, once we have that, I like to save, and then we will move all of these into a container. I'm wondering what this is, full screen in. That should be running off of, oh, that is our input. It's just kind of up here. So once we're good with that, we can add a container, and we're almost done. Well, we're wrapping up. Select all of this, drag it into your container, make sure everything's in there. Yep, it's all hungry for data. And then we can go ahead and delete everything we have selected, and then move this back into place. And then, oh, we need to arrange our inputs. So we had a resolution in here. Oh. Here it is. Okay, so data tables first, 0, 1. Textures second, 2. I kind of like to do full screen, 2. 3, 4 for our prop. And then our float values. Let's see, that's 3, 4, 5, 6, and 7. Now that we have that, we can connect our data. So this is resolution in. Okay, I feel like I'm making a long basket when I do that. This is probably our prop data. This is our full screen in. Blocked texture in. Prop texture in. And that runs off our switch. I could run that from a null, but I'll do that later. And then our required confidence variable and our prop scale min and max. Min being on top, max being on bottom. Okay, that looks good. I'm gonna save again and then zoom in, make sure we have everything. Looks like we're good to go. Let's check our outputs. This is our prop out. So we should be seeing, I think, once again, did I do it again? No, that's in pixels. Oh, because this is still receiving a blocked input. I get it. Yeah, until we get that running, this thing is kind of finicky. So yeah, kind of like we did last time, we could test this by running full screen to our blocked input. And now we get a better picture. So everything's working. Let's go to a null. We're just going to test this and then set it back. Cool. So let's set it back to running from our switch to our blocked in. And then the next thing we have to do, well, that's it until we get all three of these. So good job for making it this far. And let's move on to the next part. Next, we are going to multiply this down and make our functions. That means our monitors kind of have to go down to the bottom. This is a monitor 2, so it can go down. Everything else is good. We will go ahead and add our over here, like I said we would. And it's going to give us an error message. That's fine. Take all of this, except for the variables that we're referencing. So yes, this needs to be added as well, because this is not a global variable. This is per row. Take all of this, copy, paste, and then copy, paste. Or you could just hit paste twice. Let's clean up our boxes. And then here's what's next. So these overs, like I said, you're trying to make every single combination of texture output that can be made. Not including your monitor outputs. So that's just these overs. So what we're going to do is make a combination of the top two. All right, when I left off, I had duplicated this whole row, including this, down. I want to take a step back real quick, and before we get too lost in this wiry mess, I want to make sure we don't forget to make sure these are functions and not just copies of these top one. And then I also want to make sure that we don't get lost in these wires. So I'm going to disconnect all these wires to these overtops, and we'll reconnect them in just one moment. So first off, let's rename this one to something appropriate, like create square. And then this one, we can go ahead and steal this title, and it'll increment it for us. But then under common, we want to also fill in that name under clone master. And that will, if we come up here and add a node into this top piece, call it test, when we come in here, we'll see that the same thing exists, which is cool. So we need to do the same thing to this. And then same to this. This is apply prop. Okay. So now that we have done that, let's give it a quick Control S save. And then let's connect our overtops. Now note that bottom one is our monitor, so we don't need that. What we need is our top square texture, which is just the box. So that's going to run to here. So this over is going to be these two. Wait, I did that wrong. Let's disconnect this wire. Disconnect the top wire on all three of these boxes. Even this one. Let's just start over. All right, top is our box. So first is a combination of these two. Second is a combination of the outer two. And then the third one is a combination of the last two. Then using that, if we give ourselves multiple faces, we can see that, well, we need to, right, we need to also duplicate our dat2 and our rename. So let's Control V that to the second function and the third function. And then remember that this is row 1, so this one's going to be row 2 on both. And then this one, row 3. And then using that, it will get second row of information spit out here, and the third row, which should give us, still no. Oh, we need to connect them. That would help. So dat is the first one. Come on. Maybe it'll take it there. There we go. So now if we look at, let's do 2 quick nulls, well, 3 quick nulls, and just pull from our square out so we can see what's happening here. We only have 1 square in each one, but what it's doing is getting layered over the one next to it in every possible way, so that if we were to look at these monitors, which I do want to have, so monitor first, give this a little more room, monitor second, and monitor third, we can see that it blocks out, here it's getting 2 faces and it shouldn't. Actually, in all these, oh, right. It's only getting 1 face in each one. It's the over top that creates the combination. So then this gets fed to the next over, which layers it over the full screen. And then once we do that, we have a texture that can be fed into the face tracker, which is only 1 face at a time. And then because of our script here that organizes them as we go, or organizes them based on right here, based on their position, these stay relatively in place, whereas before they were jumping everywhere. It was chaotic. So now that we have 3 different prop positions, we can layer these over each other to combine them. And then add one more over. And then we layer that over our full screen. Where is our full screen? Let's take one more null. There's too many wires coming out of this thing. And there is our product output. So now we have props over everybody's face. And if we switch inputs, that is how you really kind of test and dial things in. So it doesn't like this clip that much. Kind of rejects it. But there's over the other ones, and then you want to test it as well with just one input. And see, where's my prop? So I should be getting sent into one of these. But I'm being output on none. Let's try lowering the confidence. What's going on? So yeah, here's how you test things. What I like to do is pause it, and then I can see, okay, here I wasn't blocked. So here, feeding in, oh, no, that's right. Oh, I see what's going on here. So the one thing that didn't get conveyed, the one thing that didn't get conveyed when I duplicated these is this reference right here. So switch, this is still talking to null 3 up here. So I need to drag this down. There we go. Then give this bottom switch its index. Unfortunately, I can't do a wire connection here because it won't take it. Now I should have a prop still. Why I don't? So pause it. So I have a face coming into, I thought I paused it. I guess I don't need, well, changes sometimes. I have a face going into this switch here, which means if I scroll into here, let's start with the confidence level. It's probably that. Yep. So what's my confidence level? 0.5. So I'm getting pretty inconsistent results here. I think my processing power is good enough that I'm going to turn off this res. And that just gives me higher fidelity face track info at the expense of my processor, but I got a 3000 card in there, so let's use it. Now note that I did that on this one, so I'm going to want to come into my master node or master container and shut off this res. And then it should take place on the rest of them. use input, and this third one that I modified is use input as well. So now I have a prop. That's good. We do have to see now what happened to my prop. Is it the confidence level again? Confidence level is off. Because my confidence level is 0.35. I don't know. See, there I am. So it's almost like it's stuck on a different, and I think it's up there. I've been meaning to say a lot of this is controlling your environment. So you guys didn't see this. You guys can see it now. The bottom of my curtains look like this. And if we go out to OpenCV and watch this monitor, it goes nuts when it hits this curtain. See, so it thinks that this curtain is filled with faces. So it's probably what's happening here. Like, it sees me here. That's cool. But when I go out of sight, it'll suddenly go, oh, well, it's not doing it anymore. What it was doing is going to this tree up here in the corner, wherever, I don't know, there, and sticking to it, even though its confidence level was very low. It should have gone directly to me. From what I understood from the documentation, it goes to the largest face in the scene. Anyway, if you've gotten this far, then you're up to about as far as I can get it. So go ahead and save. And then from here, it's all about using just various footage and setting all these parameters to help with your footage. Like I said, I just kind of had this project going, and then I wanted to share it with everybody. If you think there's anything you would like to add to it, feel free to leave a comment and make the changes and kind of make your own video. So yeah, that is it. Well, I guess what I'll do for you real quick is bring in another prop. So I do have a folder here called this. So let's bring in Thug Life. Why not? And so we're going to copy both of these so it keeps the same format. And then we're going to wire this into our switch. We already have a purple nose, so we need to add one more line here. And then set that to, what do I call this so I don't get demonetized? It's a twig. Sure. And then that is 0.68. And then our switch already knows that we've gone up that high. So now we can go ahead and move that over. And, well, we have a bit of work to do. Like, let's scale it down considerably. I guess that didn't work. don't know why it's so big. Oh, I see what's going on here. That's the only difference. So let's replace this fit node. Oh, yeah. Oh, now suddenly it's better. I don't know why the old one was so big. See, the only difference here is under common. I don't know. These are the same. Well, either way, so we need to offset this by a little bit. Okay, and then we need to make sure that my head goes back. That's still pretty accurate. Now, why is it twitching like that? Let's figure that out before I wrap this up. I was really over in the other project. So it's appearing in there sometimes. Why? Because my box gets moved. In both? Probably. No, in just one. Strange. Wait. No, it isn't. It's disappearing in the bottom one, but not the top one. Okay. It's interesting how the rate of it right now. Oh, I'm willing to bet that's why, because this is only updating every 3 frames. So that's kind of one consistency thing I didn't tell you about, is this how often it occurs. If you set this to a really high number, you'll get really smooth tracking because it's not updating much, which is good for a photo booth where, well, not in a case like that, where people come in and then their position gets known, recorded, and then the photo is taken. But if they're moving around really fast, that's not a good application for it. So if you were feeding in live television, bad application for this to be at 100, then you'd want it kind of more like every 3 or 5 frames. So I'm going to turn this to every frame, which is 0. And see what improves. Actually, looks like texture is getting ahead of my glasses there, which is strange because I thought I cached it in here. Oh, I'm delaying the wrong thing. that explains it. Yeah, I'm delaying the glasses. My bad. So, fit. If the transforms are plugging into here, that's clearly not my overlay. So this goes straight to the over. What this cache goes to is your full screen. My bad. And then that texture gets passed to the bottom of your over. And then, yes, that gets split between your prop out goes to here, and then your monitor out goes to here. So now let's see what's going on. There we go. And it is 2 frames. Did I set it back to 2? Or is it still at 4? It's still at 4. So 4 is a bit too many frames. There we go. Actually, 4 may have been correct. It seems processing is a little slow. Let's go 3 frames. There we go. That's a little tighter. So that about wraps things up. Just some final touches is to kind of get these 2 monitors so that you can kind of see what's going on a little bit better. And then, yeah, just keep on saving, keep on modifying. I will tell you I use ChatGPT to build a lot of this script. So that said, it knows it very well. And modifying it is easy. The hard part is getting it to write out the entire thing. So what I would recommend is if you have to have it modify it for something, just paste the block in and then it'll only spit out that block. Otherwise it might run out of juice by the time it gets down to these lower lines, and then you might not know if that's 100% correct. But yeah, ChatGPT wrote most of this. It does know a lot about the OpenCV and CV2 libraries. So yeah, feel free to have it answer some of those questions. I am going to wrap this up now. And yeah, if you have any questions, please leave a comment. Look forward to hearing from you guys. Look forward to kind of getting in a new audience from some of this, and kind of showing my lighting audience what I've been up to. I am going to be using Touch Designer to make a lot of lighting related stuff, so stay tuned for that. But yep, thanks everybody. Happy creating. Look forward to seeing what you guys make. So take care.